Hey guys, Mr. Rysz here. So this is going to be part 3, the last part of the 1.2 notes. Today we're going to talk about the last types of transformations of a functions, and really we're going to look at reflections, and then also a little bit about stretching here. Okay, I need a screen share. Here we go. Let's go to our notes and get this started. So if we look at our notes, the two reflections that we're going to look at is over the x-axis, so an up and down reflection, and then the y-axis. To do an x-axis of reflection, we're going to multiply the outside of the function by negative x. To rotate around the y-axis, we multiply the inside of the function by negative 1. I'm going to say negative x. So let's look over this x-axis reflection here. So if we have the absolute value of x, and if I multiply the outside by negative 1, it becomes negative absolute. And you can see that gets flipped over. So that goes from a b to an upside down b. Same thing here with the square root. If actually there should be a negative on the outside of that square root there. I go ahead and I need to put a negative here. This should be the negative. We'll add that to our little notes here. There we go. Negative f of x would be a negative square root of x. So what that means is, like, say we have a function. Like screenshot that as well. Okay. So say we have a function here that's like f of x, even if it's like really complicated, like 3x squared plus 2x minus 5. You know, I could look that up on Desmos. What that probably looks like on Desmos is a graph like this. If I want to flip that over the x-axis and make it a graph that looks like this. Ooh, didn't mean to do that. Start back over again, Rysz. All right, let's say again. Function. Sorry, technical difficulties here. Is this working? No. Hey, okay. So say we have an equation that is, 3x squared plus 2x minus 5. On a graph, that might look something like this. If we want to flip it over the x-axis, make it look something like that, what we need to do is multiply the whole function by negative 1, meaning we need to take the whole thing and times it by negative 1. And so what that means is we're going to go through the equation and change all the signs. So f of x would be, or negative f of x, the flipped of that would be a negative. We'll distribute the negative sign here to all three parts. Negative 3x squared minus 2x plus 5. So that's how we can take any function, no matter what it is, if it's a very simple parent function or it's a more complicated version of it. If we want to flip it over the x-axis, we multiply the whole function by negative 1. Now the y-axis, you can see here, if we want to flip it left or right, what we're going to do is multiply the inside of the function by negative 1. So what does that mean towards our equation? So if we had x cubed, it would be negative x cubed. Or the square root of x becomes the negative square root of x. So if we go back to that expression here and how it's just slightly different from before. So say we had our original function was 3x squared, what did we say, plus 2x minus 5. If I want to flip this over the y-axis, I'm going to do f of negative x, which means I'm going to take the whole thing, but take each individual x and make them negative. Now, a lot of times that's going to change the sign to everything like it did before, but not all the time. So in this problem here, our flipped function over the y-axis, if we take a negative x and square it, negative times negative is a positive, so that still stays a positive 3x squared. But 2 times negative x does change that to a negative 2x, and the negative 5 doesn't have an x, so that's not going to change either. So literally that's the only number that would change, and that's the only thing that will make it flip over the x and y. So if our graph looked like this, if I flip that over the y-axis, going to be basically the same thing, very similar, and that's why there's only a little bit of a difference. Okay, the last thing that we're going to talk about is shrinking or stretching. The one thing about this is sometimes a vertical stretch is the same thing as a horizontal shrink. So if you think about it, you know, if you're looking at an image, in fact, I could probably click this image here. Like if I wanted to stretch this image out, I could think of it two different ways. So I could take it vertically and stretch it out, or proportionally, it'd be the same as taking it horizontally and shrinking it. So that's why it does get a little bit difficult, because you can do two of the exact same things, and if this is a function that goes on forever, it's not going to change too much. The only thing that's different that we won't ever get into, because it's very nitpicky detail, is are we stretching from the origin or from other points in the direction it goes. So if we scroll down here, if I take a, I got one more period. All right. If I take a vertical x squared and I stretch it vertically, I can multiply the outside number by 3, and that makes it taller. What do you think about it? If we multiply an outside number, you're taking the y, and you're just making all those numbers bigger. So instead of being at 1, 1, it's at 1, 3. All right, if I multiply by a small number, like a fraction, it makes it shorter. So fractions you think are shorter versions, they make them shorter, fatter. Horizontally, stretch them out. Now, if I go on the inside of the function, it does the opposite of that. Just like how the inside of the function, when we add or subtract, does the opposite of moving it left or right. If I take a bigger number inside, it actually makes it smaller horizontally. All right, so hopefully this helps you guys. You have a CYU to do to finish this section up. This one's a little bit more abstract, a little tougher. Just remember with the CYUs, you guys can do or try as many times you need. All right, so we'll end this unit here, or end this section. We'll see you guys next time. Have a great day.